In this video, we're going to be considering factorizations. And now, it's important to reconsider the naming scheme that we had for multiplication. Okay, we had two numbers that we're multiplying. One is called the multiplicand, and one is called the multiplier. Okay, while those two numbers and their names have very specific meanings, we have a more general term, a more generic term. That's if you have two numbers that multiply to some other number, those two numbers are also known as factors. And so all numbers can be written as the product of two numbers. Sometimes you can have more than one pair, but they always come in at least pairs. So let's see what I'm talking about here. And now we have to be very cautious. When we're dealing with factors, you'll notice that it only involves multiplication. There's no addition, and therefore there's no remainder to take into account. So if a number does not divide another evenly, it is not a factor. Let me write that down. If a number doesn't divide another evenly, that means there's no remainder. Remainder. Then the first number is not a factor of the second. And this just comes straight from the definition of what a factor is. Second number. Okay, so now we'll go into what it means to divide something into a little bit more detail, as well as how to tell if a number could perhaps go into another number. But let's take a look at this, the number 24. And we're just going to, we're going to write all the factor pairs. I refer to them as factor pairs only because there's always two. So I'm not looking for factor triples or anything like that. I'm just looking for pairs, just plain old pairs. And so the way that I do this is I go ahead and I draw it down two lines. And you know, everybody develops their own way of doing it. Now I start at 1. Again, you can develop your own way of doing it. I try to do everything very logically, very repeatably. And so I don't want to kind of wonder halfway through, am I doing it right? So I start with the number 1. I say, does 1 go into 24? Yes, 1 goes into everything. It's 24. Okay, now look at the number 24. It's even, and so therefore 2 goes into it. 2 times what is 24? Let's see, well, 2 times 10 is 20, so 12. Now 3 will also go into 24 because it's 3 times 8. And then it's 4 times 6. And that's it. If we continue to go, it's just going to repeat itself. Once these two numbers here switch places, you're done. 5 does not go into 24, but 6 does. At that point, all you're going to do is you're going to get a repeat of the first 4 pairs, but in reverse order. Okay, let's go ahead and try another one. The number 72. Again, I recommend going ahead and making a factor. They call this, some people refer to this as a factor tree. Be very careful on this because the factor tree is used for something called prime factorization. We'll do that in another video. But in this, if you want to call it a tree, this tree is only going to have 2 branches. Start with the number 1. 1 goes into 72. 2 also goes into 72. And it goes in there 36 times. If you need a calculator to do these things, by all means use one. I am not anti-calculator. 3 goes into 72 24 times. 4 goes into 72 18 times. 5 does not go into 72. However, 6 goes into 72 12 times. And then 7 does not go into 72, but 8 does 9 times. And you'll notice these numbers down here got really close. If we continue on, we're going to go to 9 and 8, and that's just going to reverse. So we have these 6 factor pairs. And that's the fact that we can call that the factorization of 72. Okay, so now you'll notice that whenever I divided either of these numbers by one of their factors, I had no remainder. I never got a remainder. If you get a remainder, it's not a factor. So if you ever get a decimal answer, it's not a factor. Go ahead and give a couple of these a try. I recommend doing something fairly small to begin with. Probably something along the lines of well, let's say 16. So start that. Pause the video, take a crack at it, and then go ahead and start the video again to see what the answer is. And the answer to this is 1 and 16, 2 and 8, 4 and 4, and you're done. Okay? In the next video, I'm going to talk about prime factorizations and how it differs slightly from this style of factorization.